you doing today? Once again, you're welcome to another fascinating math video. But this time around, we're taking past problems from indefinite integral. So these are problems taken from integration, and they are all past questions. All right. So we want to show how we can integrate these integrants. So let's go back to the solution. But before that, let me inform you that I render an online private stroke group mathematics tutoring service. So if you're interested in such a service, be very free to get across to me. And also, I also render assistance in assignments, tests, projects, and research work. So if you're in need of any of these services I've mentioned, be very free to get across to me. I'm a very qualified candidate for this. All right, and you will enjoy. I guarantee you, you're going to get a full explanation on any of the topic you choose to in mathematics. All right, because I've been into mathematics for quite over a decade now. Over a decade, I'll be instructing various students from different levels. So be very free to get across to me for this service. So let's go over to the solution of these particular problems. The first, we are to integrate solution. We want to integrate the arctan of x over 1 plus x squared dx. Now, this expression, as I used to say in other videos, this can be written as the integral of the arctan of x over 1 plus x squared. That is become dx by du with respect to u. All right? We can provide a proof for this. Take note, not that du cancel out du at the denominator. Hence, you see me calling it dx by du. I did not say dx over du. These are different concepts. Don't confuse a derivative with a fraction. All right? So it is true that this expression over here can be written as this. All right? So take note of that. If you want to prove your comments, I will provide a video for this particular point. So what we do, this derivative ds du suggests to us that there is x is a function of u. Now, there are various opinions on how the function should look like, but we choose the function in such a way that the integrand will simplify considerably. That is, it will reduce to a standard form. All right. So how do we make such a substitution? Generally, it's based on your strength on the differential calculus. You can do that. So in this case, I will say let u be equal to the arctan of x. Can you see that? Now, in this case, x is a function of u. This expression over here, this expression is showing that we have a composite expression. So we shall differentiate this in order to get the s du. We shall differentiate this compositely. So on differentiating, we have, we have differentiate this with respect to u. With respect to u, we have 1 here. All right. Then differentiate this, you have 1 over 1 plus x squared. Can you see that? Then we have the x by du, because x is a function of u. Don't forget that. Can you see that? Then in that case, it follows that the x du is equal to 1 plus x squared. So on substitution into the formula, into the expression, the integration expression, we have therefore that the integral of arctan of x over 1 plus x squared with respect to x is equal to writing the integral. We say let this be u. I mean this over here. Can you see that? This be u. So we can put u over there over 1 plus x squared. Then the x du has been obtained to be 1 plus x squared. So we have 1 plus x squared in the place of the x du with respect to u. So this we cancel out and reduce to the integral of u du. And this is a very familiar form and standard form, which result is u to the power 2 over 2 plus c. So the work is done. So what we need to do is to resubstitute back our expression. We say let u be arctan of x. So in the place of u, we shall put arctan of x. So that means I can say therefore the integral of arctan of x over 1 plus x squared is equals to, in place of u, I'll put arctan of x because u was it, or to the power 2 over 2 plus c. And this is the answer. To verify the correctness of this integral, you integrate this expression here, and you see that we get the integrand. All right. The integrand is a function to be integrated. That is this function we call this the integrand. All right. Why this is the integral, and it's a definite integral. All right, so if you want to confirm whether you are correct, if you differentiate this expression, you will see you will get this again. That is how to check for correctness. So we're done with this problem. We'll go over to the next. Number 2. Number 2, let's see what is there. This one look like a monster, but it's easy. The integral of 4x arctan of x minus 1 over 4 brackets 1 plus x squared to the power 0. I think so. Let me check it to confirm. 4x arctan of x minus 1 over 4. All right, I think we are there. Yeah, we are there. Now, this problem, there are various ways to go about it, but I'm going to solve it in a very special way. So now we advise you to pay close attention so that you get the method I want to use. And instead of solving this problem directly, we can use this problem depends on some integral. Now consider this integral. Consider this, the integral of x arctan of x over 1 plus x to the power 2 or to the power 3. Let's consider this integral and see what can come out from this. You will discover that this particular integral over here has certain connection with this, and because of that connection, we can from this get this result. All right. So there are other ways to go about solving, but I choose to display this technicality. Now, this can be arranged as the integral of x over 1 plus x squared or to the power 3 multiplied by arc tan of x dx. All right. Now, what we shall do, we shall use the integration by part formula, because if you observe carefully, this is a product. Can you see that? The product. So what we do on using integration by parts, most times you choose the function that simplifies easily on differentiation. All right. So that is what you choose as your u. You know, the formula is, let me quote the formula once again. The formula is we have u dv dx with respect to x to be equal to uv. I'll explain everything here so you can get a full grasp of it. Minus integral of v du dx with respect to s. So let me explain the formula so you get it clearly. Now, in using this formula, we are to take note, this is a product, all right? And this expression is analogous to this special expression. This is a general expression, all right? This one is a particular expression. And in this case, what we do, we choose our u to be the function that simplifies easily on differentiation, all right? Now, if you observe carefully, you will see that this expression x over 1 plus s squared or to the power 3, that will not simplify easily on differentiation. So rather, we take our u to be arctan of x, all right? So let's take our u to be, so let this be u, all right? Now, if you observe the formula here, you see, look at the formula here. Can you see that? If you observe the formula on the right-hand side, you see that this u we are choosing was differentiated. Look at it here. Can you see that? It was differentiated. That means after making our choice of u, we have to differentiate that choice to get the u ds. Don't forget these things I'm saying, very, very important. Then also you will see then the last expression, which is this, we call it our dv dx, all right? And to get v from it, we integrate. So the choice we are making is u and dv ds. We can get du ds by differentiating the u we've chosen, and we can get v by integrating the dv ds we have also chosen. All right, so take note of these points, very, very important. So in that case, following this formula, I will have this as a result. I can say therefore the integral of x arctan of x, okay, let me write this, let me come from this point instead. Let me write x over 1 plus s to the power 2 or to the power 3 arctan of x dx, all right? Now, in this case, these are u. Now, recall, what do we choose as u? Can you guess? I give you 5 minutes. If you say x over 1 plus s squared over raised to power 3, you are wrong. But if you say arctan of s, you are right. All right, so that's our u. So we can write this as arctan of x, all right? Multiplied. Now, to get this v,